Welcome back to my Rust series. In this video we'll talk about functions. We already have defined a function in Rust. If you've been following this course since the beginning, that's the main function of course. A function in Rust is defined with the fn keyword followed by the name of the function, parentheses which are supposed to enclose any parameters of the function, and then a scope block which denotes the function body. If we want to define another function in this file, let's say I'll call my function another function actually, and let's have it just print some text, just another string. Alright, so this function is currently after the main function in terms of where it's defined, but that doesn't matter, I can still use it. Rel doesn't care as long as the function is in scope. If I now run my project, you'll see that another function is executing and the macro within it prints the string to the console, as it should. Now let's use parameters. In order to use parameters, I'll first rename my function to print number, and I want a parameter that's a number, so I'll do x and I'll define it as unsigned 32-bit integer. It doesn't really matter, it's for demonstrative purposes. And what my function will do is it will say value of x and then print x. Quite straightforward. Notice that we do need to denote parameters with a type. Now, if I use my print number function, I need to use the parameter. As I'm told by IntelliSense, it expects an argument, and I'll just enter some unsigned integer. If I run my program now, it's working as expected. The argument is passing to the x parameter and we print it. So far my function does not return a value. But before returning a value from a function, I want to make a few remarks about statements and expressions in Rust. To do that, I'll do a simple example. I'll define two variables. They'll be integers for now, I'll call them x and y, and I'll leave them undefined. Let's say that we want both to have the value of 12. I can do this like that, right? Just assign both the value of 12. I can even print them right now to verify that everything is working. X and then Y. If I run my project, everything is working as expected. Both values are printed and assigned correctly, right? Now, in most C-based languages, that's C, C++, C#, whatever, you can assign x the value of y and then assign y the value of 12 on the same line. And that will work in C-based languages because an assignment y equals 12 is actually an expression there, and it returns the value which is assigned, 12. If I attempt to run this in Rust, as you can already see by VS Code's IntelliSense, I will actually get an error for mismatched types. You see that x is expecting a 32-bit signed integer, but instead a unit is returned. This is an empty tuple, or also called a unit in Rust, and it's returned by statements. In Rust, an assignment is a statement, and a statement does not return. Expressions, on the other hand, return a type, and they can be used to assign a value to something. I'm telling you this because we need to know the distinction between statements and expressions in order to create a function that returns in Rust. And statement and expression differences are quite pronounced in Rust compared to C-based languages. Now, let's make a function that adds two numbers. I'll call it another, and it will accept two arguments, two integers, x and y, pretty standard. Now, to denote that this function returns, we use this symbol, and then we have to denote the return type. In that case, it will be, again, an integer. Now, in order to return x plus y, we just have to write x plus y. Notice that without a semicolon at the end, this is actually an expression. If I add a semicolon, this becomes a statement, and it will return a unit type, which will mismatch the 32-bit integer type. Let me demonstrate. If I print something which uses the other function, I'll call it result, and then I'll use other to add 1 and 2. Alright? Right now, I don't have a semicolon, so this is an expression. If I run my program, I see the correct result and my program compiles successfully. If I add a semicolon here, this becomes a statement which returns an empty tuple, a unit. And we have a type mismatch. Now if I run, I will get an error. And you see that the function expects to return an integer. Instead, we return a unit. As you can see, we also have a helpful message that tells us that the most likely error in our code is the semicolon, which turns this expression into a statement. If I remove it, everything is working correctly. As you can see, I don't need to specify return here to return x plus y, although that would work just fine if I run the program right now. You see that it works. And we can use that to return early, for example, an if statement before the actual last line of the code in the function body. But by default, if we have an expression in the last line of the function, it is automatically returned. And we can have any other code here to get the actual expression which we have to return in the end. Another useful remark, any scoped code block in Rust will actually evaluate to the last expression in it, which means that I can define a variable, let's call it example variable, and it will have an integer type, and I can assign it to a code block. In this code block, I can execute a couple of lines of code or whatever, and if the last line is an integer expression, that will assign 32 correctly to example variable. Let me print it to demonstrate that. If I now run my project, you see that value of example var is 32. So this basic concept about a code block evaluating to its last expression is not just valid for functions, but for scoped code blocks in general. With this, I'll wrap today's video. Don't forget to subscribe to get notified when the next video in the series is released. Take care.